So I'm going to start with 2, and I'm going to just factor 2 and 16, 2 and 8, 2 and 4, 2 and 2. We can actually use the same number for 64. And you'll notice it looks very similar. It's going to be all 2s as well. Just one more. All right, so we're looking for groups of how many? 4. So we're going to take 1, 2, 3, 4 there, right? And we can take out a 2. And we can group if we need to. I don't think it's actually going to matter, but there's 4 more. And if you'll notice, I have 1, 2, 3. That's not enough, right? And so those 3 are going to stay inside my root. And then I'm just going to simplify it. So I'm going to multiply the outside, multiply the inside. All right. And then once I do that, I have my answer. And for my numbers, I'm going to do it exactly the same. 2 actually has no factors. It's just a prime, so it's just itself. With 8, I can factor this one. And for my numbers, any of these can group. So I have a 2 that groups here, and these 2 can actually group as well. So all my numbers actually come out here. All my numbers come out. For my variables, I'm going to multiply w to the 15th times w to the 1st. That is w to the 16th. Z cubed times z, that is z to the 4th. And then I can use my little division trick. I can divide the exponent by my index. So I can say 16 divided by 2, that is 8 with the remainder of 0. For the z, I can say 4 divided by 2, that is 2 with the remainder of 0. So I am going to have, for my w's, 8 will come out, none will stay in. For my z's, 2 will come out, none will stay in. So I actually have nothing that stays inside the root here for this one. And I am going to end up, when I simplify it, with a 4w to the 8th z squared. All right, so dividing radicals, the first thing they tell you is, and first of all, if it's division, if it's a root of a 0 in the numerator, then it's just 0. But if it's a root with a 0 in the denominator, that can't happen because obviously we can't divide by 0. So that's what that first part is telling you. The second part is just saying when you are taking a radical with a fraction, whether it is the whole thing inside of it or the whole thing outside of it, it's really the same thing. You can either do the root individually or you can reduce the fraction inside the root and do it that way. And so we're going to look at both ways of doing this, but then we're going to actually get the radicals out of the denominator altogether. And so we're going to do this property a couple times and you're going to see it. And I promise you're going to use this in geometry as well. So let's look at dividing radicals. The first thing it says is simplify square root of 40 divided by square root of 5. These have to have the same index, and they do. And so if we have it, we're going to write it like this. This is actually how you're normally going to see it. What they're telling us is you can actually put the whole thing under the root. So we could say 40 over 5. All right, and we can reduce that. What is 40 over 5? It's 8. And then we're going to simplify this 8 just like we've been simplifying all of our radicals. We're going to use our factor tree. That's 2 and 4, 2 and 2. What pairs up? That does, right? And then we still have 1 that doesn't pair up. So this is actually going to simplify to 2 square root of 2. So if I said square root of 40 divided by square root of 5, I'm going to get 2 square root of 2. That is my answer. All right, let's look at the next one. This example. So these are both in the radical, both with the same index, all right? So we can reduce it. You can put it under the same radical if you want to. You don't have to. But we can reduce it. What goes into 12 and into 15? 3. So as long as both numbers are inside the radical, you can reduce. Or if you have numbers outside of the radical, you can reduce. But you cannot reduce from inside to outside, okay? So you can reduce inside to inside, outside to outside, but you can't reduce the other way. So we can actually divide both of these by 3, just like we would reduce a normal fraction. So on the top, we're going to have the square root of 5. And on the bottom, we're going to have the square root of 4. What else do you think you can do there? So since they are both within radicals, even if it had been square root of 5 over 4, you can do the 4 individually. So we can say, well, leave the square root of 5. That does not have a perfect root, but 4 does. And so I'm going to change it to look like that, the square root of 5 over 2. All right? Even if it had been like this, you can do that. You can split it up. So it doesn't matter if it's all under the root or if it's individually under the root. You can individually reduce them out of the root like that. So fractions with radicals in the denominator or radicals with fractions in the radicand are not considered simplified. So square root of 5 over square root of 7 or square root of 5 over 7, either way you look at it, neither one of those are considered simplified. Having a radical in the denominator is like leaving something in the form of like 2/4. You would never give me the answer 2/4 because you could simplify it 1/2. And so having a radical or a root in your denominator is not considered most simplified. And so there's a method to get it out of the denominator when it's not a perfect root. We had square root of 4 in the denominator. It was easy to get the radical out of that guy because square root of 4 has a perfect root, okay? But when you have something that is not a perfect root, then you have to get it out of the denominator with rationalization, okay? And so we're going to do that process in the next problem. Square root of 5 over square root of 7. There's absolutely nothing I can do with either of those radicals. First of all, they're prime. Second of all, any prime actually in a radical, I can't take out of it, right? Unless it's a perfect root. And neither one of these are perfect roots. And so the only thing that goes into them, like any prime, is 1 in the number. And so the only way to do this then is rationalizing, okay? And so the way we rationalize is we actually take that denominator and we multiply the top and bottom by the denominator. So I'm going to show you in something as simple as a normal fraction here. If I have 1/2 and I multiply the top and the bottom by, let's say, 2, did I change my fraction? Or does it equal the same thing that I started with? It's the same, right? So 1/2 and 2/4 are exactly the same. So multiplying the top and the bottom of a fraction by the same number does not technically change the fraction. It just gives you an equivalent fraction. Just like if I were to be given 2/4 and I were to divide top and bottom by 2. I didn't change my fraction, I just simplified it, okay? And so that's what we're about to do. We're going to take this and we're going to multiply the top and the bottom by that square root of 7, all right? Now we have done this in the prior sections. Square root of 5 times the square root of 7. What is that? The square root of 35. What is the square root of 7 times the square root of 7 then? 49, right? Now, hopefully you can see that I can do one more step now. What one more step do you think I can do? Simplify that denominator. What is the square root of 49? 7, all right? Anytime you multiply a square root by itself, you end up with the root just going away because the square root of 7 times the square root of 7 is just 7 outside of the root, okay? And then because I multiplied the top and bottom by the same thing, I did not change my fraction. This fraction that I started with and this fraction that I ended with are the same thing. Just like 1/2 and 2/4 are the same thing, okay? But this is actually considered simplified because leaving a radical in the denominator is not considered simplified, okay? And so when you get these, you're going to get them as small as you can. And then if you still have a radical in the denominator, you're going to do this process. You're going to rationalize the denominator. Let's look at the next example, all right? Square root of 3 divided by the square root of 6, all right? So first of all, I'm going to write it like this. The square root of 3 over the square root of 6. Before I rationalize, is there any simplifying I could do? Yes. What can I do? They're both inside the root. I can reduce them. How does 3 over 6 reduce? Yes, square root of 1 over square root of 2. There's one more thing I can do. 1 always has a perfect root. What is the square root of 1? 1. 1 times 1 equals 1. And so now I can simplify this even further, and I can say, well, that's 1 over the square root of 2. And now I have done as much as I can do, and I still have a root in my denominator. So I am now going to do rationalizing. I am going to take this, and I'm going to multiply the top and the bottom by the square root of 2. 1 times the square root of 2, well, 1 times any number is just itself. The square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 equals 2. I cannot simplify this. Why not? Why can't I reduce that 2 and that 2? Right. One of them is inside the root, and one of them is outside of the root. I promise, in your brain somewhere, you're going to want to reduce this, but you cannot. The square root of 2 is not the same thing as 2, all right? Those are two different numbers. Those are two different numbers, okay? And so I can't reduce this. This is my final answer, and I am done with this one. And so the square root of 2 over 2 is how I am going to leave that one. Look at this one. The square root of 2. Can I do anything with that? No. Can I reduce 2 over 75? No. So then let's look at 75. Can that be simplified any way at all as a root? Well, potentially. Let's factor it. What goes into 75? An easy prime that always goes into things. Yep. All right. So 5, and it goes in how many times? 15, and then 5 is going to go in it again. All right. That's all primes. So what can I reduce out of that? What's going to pull out of the root? A 5 is going to come out. A 3 is going to stay in. So that's as simple as I can get it by reducing and simplifying, right? Now I need to rationalize, all right? I only rationalize what's in the root. I don't do anything with the 5. I can have a 5 in the denominator. I cannot have a square root of 3 in the denominator. So I'm going to multiply the top and the bottom by the square root of 3, all right? On the top, 2 times 3 gives me the square root of 6. Down here, I still have a 5. It is now being multiplied by the square root of 3 times the square root of 3, which is just square root of 9. Square root of 9 is 3, all right? And so then I'm going to multiply these two, the 5 that was on the outside and what this simplifies to. And I'm going to get the square root of 6 over 15. I cannot reduce the 6 and the 15 because the 6 is inside the root. The 15 is outside of the root. So I am done. All right, so for this particular one, I am going to see, can I reduce the outside numbers, 25 and 9? Do those reduce? Not those don't, but what does reduce between top and bottom? The 3 and the 15. So the first thing I'm going to do is leave that 25 there. Instead of 3, we're going to divide top and bottom by 3. All right. I can simplify one more thing before I need to rationalize. What can I do here?
1.
Yeah, that 1 is just the square root of 1. So I have 25 times 1 on the top. So I have 25 on the top and 9 square root of 5 on the bottom, right? What else can I do now? Anything else reducing? So my next step is going to be to what? Yeah, multiply the top and bottom by this. All right. So far, so good. So on the top, I have 25 times the square root of 5. On the bottom, I now have 9 times what? Square root of 5 times square root of 5 is the square root of 25, and the square root of 25 is just 5. All right? Before I multiply those, do you think I can reduce anything? Yeah, I can. Now this is on the outside and this is on the outside. Everybody see that? And so I can reduce those. 5 divided by 5, 25 divided by 5. So before I even multiply, you may be able to reduce something once it's outside of the root. So now I'm left with 5 square root of 5 on top, 9 on bottom. I cannot simplify anything else. I am done. If they didn't already give it to you that way, if it's spread out, write it in fraction form. Simplify any inside to inside, outside to outside, and then simplify any radical. So if you have a radical that you can factor and pull something out, do that as well. All right? And then whatever you have left, if there is a radical in the denominator, you're going to rationalize to get rid of it. So I want y'all to try a few.